Okay, let's look at this review problem that involves converting decimals to fractions in lowest terms and then to fractions in the specialized forms here. Let's just get some practice with this. 0.124, that is a decimal, and so we need to convert this either as a lowest term fraction or in the form expressed here. The latter is the easier to do. Clearly this is equal to 124 over 10 to the third, or 124 divided by 1,000. And then it is just a matter of canceling to get this down to lowest terms. In our case, the top and bottom are both divisible by 4, and so I would get 31 over 250. And that would be the answer. And let's just double check that over here. So 31 divided by 250 is indeed 0.124, and we know already that 124 divided by 1,000 is also 0.124. Sticking in the first column, 3 over 64. That is a lowest term fraction, and we have to convert this to either a decimal or into the desired form. Converting to a decimal, clearly we can just simply divide, so we could simply do 3 divided by 64 to get 0.046875. Slightly more elegantly, we notice that 64 is 2 to the 6th power. And so this will be equal to 3 times 5 to the 6th divided by 2 to the 6th times 5 to the 6th. And 3 times 5 to the 6th power is 46,875. Divided by 10 to the 6th power. And then that's instantly convertible to a decimal point, 0.046875, which is what we saw before. Okay, the last entry in the third column is 123. Or I'm sorry, last entry in the first column is 123 divided by 10,000. So that's already in the form m divided by 10 to the r. It's also a lowest term fraction. And so that is instantly convertible to a decimal point, 0.00123. Okay, so that is the first column. The terminating case is certainly the easiest of the cases. Let's now take a look at the problems in the second column. 0.386100 bar. And we need to convert this into the other two forms. That's the decimal form. We need this in the forms here. From one of our theorems in class, we can immediately write this as 386,100 divided by 999,999, because the bottom is 10 to the 6th minus 1. The repeating block has length 6, and so we can just simply write that as a million minus 1, 10 to the 6th minus 1 as the denominator, and the numerator is simply what's left up here. Okay, so that is the form here where r is equal to 0 and l is equal to 6. Okay, then the only question is to convert this into a lowest term fraction. And to do this, let's figure out if these two numbers have any common factors. Well, let's get the prime factorization of the denominator. 999,999. So let's start working on that. Clearly, you can divide that by 9 and divide that by another 3. So that takes us to 3 to the third. And clearly 37 is a factor. and 1001, we can do the 11 test and see that 11 is going to be a factor. 1 minus 0 plus 0 minus 1 is 0. That's a multiple of 11. So if I divide this by 11, I get 91. So there is your prime factorization of the denominator. So we'll check to see if any of these numbers happen to go into the numerator. So divided by 3, it works. Divided by 3 again, works again. Divided by 3 again, still works. So we can pull out 27 out of the numerator. Let's see if 37 works. Nope. Okay, let's see, should 11 work? Well, 1 minus 4 plus 3 is 0, so 11 should go in. And 91 probably does not, but let's check. It does not. So I have successfully pulled out 27 times 11, which is 287. So let's double check that. 999 divided by 287 is so 297, I apologize. 999 divided by 297 is 3,367. And on top, 386,100 divided by 297 is 1,300. And so there is your answer in lowest terms. Okay, 4 over 39. Okay, let's see if we get any luck from the calculator to see if we get a hint as to what the decimal expansion might be. And it looks like the decimal expansion might be 6.102564. So how do we check that for certain? Because we see 1026. Now, based on the calculator, we don't know this for certain because we could be 10261, and that would not be repeating. So the calculator suggests that the period might be 6, but we don't know that for certain yet. So the way that we can test that for certain is if we can somehow write this as something over 10 to the 6th minus 1. So how do we solve for the numerator here? Well, let's see. 999 divided by 39 it works out even. So if I multiply that by 4, I get the numerator. So 102,564. As expected, 102,564. And so we know that this is 0.102564. Now I want to emphasize that we did not simply just look at the calculator and say, ah, yes, the period must be 6. Because based on the calculator, we could have something different after the 26 here. We have to confirm that, and we confirm that directly by checking that 39 is a factor of 10 to the 6th minus 1. Continuing on, and I should have realized this earlier, that 91 is not prime. That's 3 to the 3rd times 37 times 11 times 7 times 13. And so I should have checked this up here. This is not correct. 13 goes into both the bottom and top. 1,300 divided by 13 is 100. And 3,367 divided by 13 is equal to 259. So I apologize that I did not properly reduce that to lowest terms because I thought that 91 was a prime number. Okay, lastly, 348. Or sorry, 3,478 divided by 10 to the 4th minus 1. Well, we can immediately write that as 0.3478 repeating. So that's automatic. To get this to lowest terms, we first find the prime factorization of 9,999. Now clearly 9 and 11 are factors, so I shouldn't write 9 as a prime number. 3 squared times 11. And I believe what's left is going to be 101. So let's check that. 3 times 3 times 11 times 101, which is going to be 9,999. So let's see if any of these numbers go into the numerator. 3478 divided by 3 does not work. 3478 divided by 11 does not work, and those could have been checked directly. 3478 divided by 101 does not work either. So 3,478 divided by 9,999 is indeed in lowest terms. Okay, now let's move on to the third column. First off, we have 0.00, let's count the zeros, 2, 3, 4 zeros after the decimal point, 27. So from a theorem in class, we can immediately write this as 27 divided by, let's see, we have 4 zeros here, so 10 to the fourth, times, and the repeating block is length 2, so 2 squared minus 1. So 27 divided by 99 times 10,000. Now clearly I can cancel 9 from top and bottom, so that leaves me 3 divided by 110,000. And let's check that actually works. 3 divided by 110,000 does give me 2.7 times 10 to the minus fifth repeating. So the repeating starts on the 1, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, 10 to the minus 5 spot. And so this fraction does indeed match this, as confirmed by the calculator and as proven by the arithmetic here, and then using the theorem from class. So that's the first one. 11 over 48. All right, let's plug into a calculator and see if we can kind of guess what the answer is going to be. 11 over 48, 2, 9, 1, and then 6 repeating. So this suggests that the denominator is going to be something on the order of, well, let's see, we're going to have 1, 2, 3, 4, so 10 to the 4, and then 10 to the 1 minus 1. So that's the guess we have based on the calculator, and let's see if that's right. 10 to the 1 minus 1 is 9, and times 10,000. And if all works out, this should be a multiple of 48, and it is. 1875 times 11 is 20,625. And so that expresses it in the second form here, 20,625 over 10 to the fourth times 10 to the first minus 1. So now to convert this to a decimal, without just simply plugging into a calculator, let's write 20,625 as something times 9 plus a remainder over 90,000. So if I divide by 9, the quotient is 2291, and the remainder would be 20625 minus 2291 times 9, which is 6. Okay, then I can split this fraction up into two pieces. So this one part would be 2,291 times 9 over 90,000. And the second part would be 6 over 90,000. This first part is going to be 2,291 divided by 10,000 because the 9's cancel. So the 9 cancels here, and this 9 cancels, leaving me just 10,000. And so I can just simply write this as 0.2291. And then the second part here is going to be 0.0000, 4 zeros for the 10 to the fourth, and then 6 divided by 9, so I can immediately write 6 bar. And so I get the decimal representation 0.2291 6 bar. And so there is the decimal representation without doing any division. Okay, lastly we have, clear off some space. Lastly we have the fraction 49,732 divided by 1, 2, 3, 4, 5, 6 9s, and then followed by 2 zeros. So 99,999,900. Okay. So we note that 49,732 is less than that's 5 digits, and that's less than the 6 9s that I see here. And so I can immediately write the decimal representation as 0.00 because of the 2 zeros here, then 49732. Now the reason that I can write this down immediately is because of the, I'm sorry, and that's incorrect, I'm sorry. Then I have to have a repeating block of length 6, so it goes 0, 4, 9, 7, 3, 2. And these 2 zeros don't repeat, but the third zero does repeat. So this horizontal line here includes the first 0. Now let's plug that into a calculator and see if this indeed is what happens. 49,732 divided by 99,999,900. And so it's 4.9 times 10 to the minus 4. So that's on the first, second, third, fourth digit. And it goes 49732, then 0. The 0 repeats that we see here. 4973, and 2 after that. So that is the decimal representation. To write this in lowest terms, let's just go ahead and do it. What numbers go into the bottom? So we have 999999900. So on the bottom we have 2 squared times 5 squared for the 100. There, so if I divide off the 100, that gives me that. Okay, now we did this before, so let me write it down. So I've got times 3 to the third. And as I recall, I can divide this by 7 and it works. I can divide this by 11. And I can divide this by 37, leaving me 13. So that's the prime factorization of the denominator. So let's try all these out on the numerator. 49,372. Clearly I can divide it by 4. It's based on the 3 trick, 3 is not going to work. Let me show that directly. So 3 doesn't work. Let's see. Let's try see if 7 works. 7 does not work. On the 11 trick, 1 minus 2 plus 4 minus 3 plus 3. That's not going to be a multiple of 11, so 11 should not work. And the others, 13, does not work. And let's try 37. That does not work. And so in lowest terms, this will be written as 12,433 divided by whatever that denominator is, divided by 4. So that'll be 25 times 27 times 7 times 11 times 13 times 37, which is 24,999,975. 24,999,975, and I'll let you confirm that if you divide the original denominator by 4, you get this. So that's the third column. Finally, let's now take a look at the fourth column. So 0.12345, where the 345 is repeating. This can be written as 0.12 plus 0.00345. Okay, so this is 12 over 100 plus, now this part is going to be 345 divided by 10 squared, squared because of the 2 zeros, times 10 to the third minus 1, 3 because of the block of length 3. And so let's write this as 12 over 100 plus 345 divided by 999 times 100, so 99,900. Then it's a matter of just getting the least common denominator, so 12 times 999 plus 345 is 12,333 divided by 99,900. And let's confirm this actually works. If I divide that by 99,900, I do get 1.12, 345, 345, and then 345 rounds up to 35. Okay, then to get this in lowest terms, 99,999. Clearly, I can divide this by 100, so their 2's and 5's are factors. I can divide that by 9, and I can divide that by 3. So the prime factors of the denominator are 2, 5, 3 to the third, and 37. Let's see if any of those work on top. 1, 2, 3, 3, 3. Divided by 3 works. But if I divide it by 3 again, it will not work. 2 and 5 clearly will not work. Let's try 37. That also does not work. So I can divide top and bottom by 3 to get 4,111 divided by 33,300. And let's check that again. And indeed, that is the correct decimal representation. Okay, second to last, 7 over 250. That is a lowest terms fraction. This is equal to 7 times 5 squared times 10. So 7 times 5 to the third times 2. So to write this in the form m over 10 to the r, I just need to multiply top and bottom by 2 squared. So on top I get 28, and on the bottom I get 10 to the third for 1,000. And then I can easily write that as a decimal point 0.028. Okay, finally the last problem. So we have 214,97323 divided by, and here I have 1, 2, 3, 4, 5, 6 nines. And then followed by 2 zeros. So 99,999,900. Okay. Notice that the numerator has more than 6 digits. 1, 2, 3, 4, 5, 6, 7, 8. So in order to write this as a decimal, so this is in the form that's up here. In order to quickly write this as a decimal, I first need to write the numerator as something times 999, comma 999, and get the quotient and the remainder when I divide the numerator by 999,999, the denominator without the 2 zeros. So 214,97323 divided by 999,999 gives me a quotient of 21. And then to get the remainder, 214,97323 minus 21 times 999,999 gives me a remainder of a large remainder, but it's less than 999,999 over 99,999,900. Whoops. Okay, so the first, we split this up in 2 parts. The first part, we would have 21 times 999,999 divided by 100 times 999,999 plus 497,344 divided by 99,999,900. And so this first fraction, clearly these cancel, giving me 0.21. And the second block, I would have 0.00 for the first 2 zeros here, and then a repeating block of length 6. And because this has 6 digits, I can immediately write this as 497,344. Bar, where the double zero is not repeating. So I have 0.21, 497,344. And that would be the answer. And let's see if that actually works. 21,214,97323 divided by 2, 3, 4, 5, 6 nines followed by double zero. And I get 0.21497,344. And then 5 here represents the next digit 4 after rounding up. And then finally, to convert this into lowest terms, 21,497,323. We know the prime factors already. We've seen this before. Let's test them out. Does 3 work? Nope. Does 7 work? Because we know 2 and 5 do not work. 7 does not work. Let's see if 11 works. That does not work. Let's see if 13 works. 13 does not work. And finally, let's see if 37 works. 37 does not work. So this already is in lowest terms. So that's the answer. With this exercise, I mostly wanted to impress upon you that converting numbers into the full decimal representation is not as simple as plugging into a calculator. The division algorithm can be used, however, to get the digits that cannot be displayed by your calculator.